Okay, hey everybody, how you doing? We're going to work through some problems here on the board. That's what OTB stands for. Is my goofy way of talking about things that we can practice on the board. So I'm down here in the basement dungeon, the stats, my stats filming studio, and I'm ready to go. I'm ready to tell you a little bit about descriptive statistics. So in your workbook on around page 29, 30, something like that, there's an on-the-board exercise in which we're going to talk a little bit about characterizing this in terms of central tendency and variability. So what I got here is I got the data, the long variable from the smoking study, the first 10 observations, 2718, 618, 226, and so on and so forth. And they asked the question, Tim Baker and his group asked the question, what was the longest time that you quit smoking? And the answers were, the first person said 2 months, and the second person said 7 months, and so on and so forth. So we want to summarize these data in terms of their central tendency. We might want to first start by calculating the mean, or M. And M is just the sum of all the scores divided by the number of scores. So the sum of all the scores, sigma x, is we just add all of them up, right? 2, 7, 1, 8, 6, 1, 8, 2, 2, 6. So 2, 9, 10, 18, 24, 25, 33, 35, 37, 43. 43, right? N is the number of scores they have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 scores. So the mean is just 43 divided by 10. The mean in this case is 4.3. All right. So we can put a little bit, we can say mean of 4.3 over there. Now, another way to describe the tendencies, the central tendency of a data set, would to calculate the median. Now, the median is the 50th percentile. It's the distribution in which half of the scores are greater than the median and half of the scores are less than the median. So we want to find that middle score. So how do we go about doing that? Well, actually the computational formula for median are pretty crazy. So what I recommend you do as an approximation, as a guess anyways, is we're just going to line up the scores and we're going to count from the inside, the outside in, and we'll find the median. So we'll just line up our scores. We'll line them up from smallest to largest. So we got a 1, a 2, and a 2, and another 2, and we got a 6, and we got a 6, and we got a 7, and we got an 8, and an 8. So there's our 10 scores lined up from smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're just going to count from the outside in. 2, 3, 4, and this is our median, or somewhere in between here is our median. And what we say is the median is the average of the two if we have an even number of scores. So our median is equal to 4. So we can put that over here. Median is equal to 4. If we want to count the mode, right, if we want to determine the mode, MO, is the most frequent score. And if we look at all the scores, it looks like 2 is the most frequent score. So that is our data from, in terms of characterizing in terms of central tendency. Okay, so we also want to characterize this distribution in terms of its variability. So variability, we want to determine its variance and its standard deviation. Well, variance is equal to 1 over n minus 1 times the sum of the square deviations of each score from its mean. Okay? So what we need to do is we need to calculate the difference between every score and the mean. Then we need to square it, then we need to add it up, and then we need to divide it by n minus 1. So what I'm going to do here is I'm going to translate some of these values over here. Mean is equal to 4.3, median is equal to 4, mode is equal to 2. just to get them out of the way, because what I'm going to do is I'm going to erase this. So what we do is we have our long variable, and then we have the mean of the long variable, which is 4.3, 4.3, 4.3, 4.3, 4.3, 4.3, 4.3, 4.3, 4.3, 4.3. Then what we're going to do in this column is we're going to take the difference of every score minus the mean. So we're just going to do 2 minus 4.3 equals negative 2.3. 7 minus 4.3 is positive 2.7. 1 minus 4.3 is negative 3.3. 3.7. 1.7. Negative 3.3. 8 minus 4.3. Remember, we're just minusing one from the other, and we're getting a value. Let me just do this so that everybody knows where we're going. 8 minus 4.3 is 3.7. 2 minus 4.3 is negative 2.3. 2 minus 4.3 is negative 2.3. And 6 minus 4.3 is 1.7. Okay, so we have 10 deviations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are what we call the deviations of the score. Now what we're going to do is we're going to take those values and we're going to square them. So 2.3, we're going to square 2.3. And what does that equal? That equals 5.29. Then we're going to square 2.7, and that's 7.29. And then we're going to square 3.3, which is 10.89. Then we're going to square 3.7, which is 13.69, and so on and so forth. 1.7 squared is 2.89, 10.89, 13.69, 5.29, 5.29, and 1.7 squared is 2.89. Now, if I sum all of these up, right, that's what the sum of these squared deviations of a set of scores from its mean. We also know this as sum of squares, just so we're all on the same page. And if we add up all of those, we get 78.1. Okay, these equal 78.1. So variance is just 78.1 divided by n minus 1, which we determined already was 10. Right? We have 10 scores. So 10 minus 1 is 9. So our variance is equal to, if we divide 78.1 divided by 9, we get an answer of 8.6 repeat. Okay? So that's how we calculate variance, and that's pretty straightforward. Now you may be looking at this and going, man, what's going on? Why do we have to do all this work? Why do we have to, especially, why do we have to square these values? Why don't we, what's with this squaring thing? Why do we have to do that? My pen comes apart. Ooh. My red pen came apart. Why do we have to square them? Why can't we just add up the deviations of the set of scores from its mean? Why can't we use that as the term for variance? What is the problem there? Well, the problem is this. It's a mathematical property of the mean. And that is to say, let me get a pen that works here, is that the sum of the scores from their mean will always equal 0. Always. These scores, if we were to add them up, would equal 0. And they do. If you wanted to do the math, you could see that they added up to 0. So that's why we have to square them. We have to get out of this little loop, this little problem of having always having a 0. So let me put some more data, some more descriptive statistics that we've calculated. We calculated variance now to be 8.6 repeat. Now, what we want to do is we might want to calculate standard deviation, which is just the square root of variance. So S is equal to the square root of 8.6 repeat, and this is equal to 2.94. So standard deviation is 2.94. Okay.